Seems to be working fine. Let's see if we are live or not. Let's just quickly check that up. Hello, everyone. Quick plus on the chat if things are audible, visible on your end. Let me quickly put the stream link on this. Okay. Chalo ji, I think things are working on YouTube. Great. Let's I let's get started with the lead code contest. So I'll wait for a few more people to join. Then I'll just quickly set up the code contest questions. Okay. So today we just have one contest, so should be fairly quick. And I'll actually try to wrap it up a little faster because it's raining outside, and for some reason my inverter is not in its correct condition. So in case the light goes, we'll have a blackout. So let's try to quickly wrap the question ups. Even though it was easy, that doesn't mean that there might not be some new learnings. I'll try to like think about them again from scratch. Try to think about some variations that might have been possible, and maybe how to attempt those. I think that's what will be the agenda, and we'll try to make sure that we learn something, even if you have solved all four problems. And in case they're too easy, I'll make a problem harder than what it is, and then see if we can solve that, right? So that we at least have some good learning, right? Yes, I saw today like a lot of people were able to solve four problems. So like a lot of students give me feedbacks on LinkedIn ki Vivek, I was able to solve four problems and stuff. So I can see the posts and all. From that, I can understand ki what might have been the difficulty of the contest, right? Did you guys see the premiere that I've posted on my channel? There is this core CS premiere that is gonna happen very soon today. Have you guys checked that out by any chance? Vivek sir, yes. There is a so this is like a little maybe deviation from what we generally do on the channel. We generally talk about DSC and CP, but then this is one small detour to, let's say, core CS, right? I generally feel there's like a lot of content around it, but then the one video that I've uploaded for today, I think it's something that is required by anyone to be watched before they start reading core CS essentially, because it just pieces things together. Okay, so watch that up if you are gonna like do that. Let's get started. How many questions were you able to solve? Just see, let's see in on chat how many people, like how many of them were easy. Maybe we can brush past them a little faster than usual, and then we can go towards the last few problems, and then maybe look at some variations, I think. Okay, ICPC, yes. Yeah, maybe we can post there too for those who gave the contest and in the. Let me just quickly. How many questions? All nice. Chalo, great. Two. Okay. ICPC, yes, good. Posted more for others too. Unfortunately, one. Okay. No. So if even if I'm saying easy, that means that doesn't mean you like it was easy for people who are senior compared to you guys right now. So we will discuss good amount of questions. Don't worry. Okay, so let's start with the problems. Let's start. I don't want to like just keep blabbering around other things. Let's quickly start discussing the problems and think about how we can possibly solve them. Right. So let's start. I think that would be there. Good. How many of you are from ICPSC? Welcome, as like obviously, yeah. So I had a class till mid, jab tak RCB was. After that, obviously, like everybody was watching at the end. I think so. I think so. Everybody was watching at the end. Cool. चलो यार मैच वगैरह बाद में करते हैं. Let's complete the questions first. So the first problem I think was super simple. In an array, consider special if every pair of its adjacent element contains two numbers with different parity. You have to just check. So you just go through a of I and a of I plus 1 and check if they are of the same parity or not, right? हाँ थाला एक देखो I personally feel कि यार there was a zone जब he was the greatest. I think no longer. I think no longer. But again, I do love. I am no longer like too much into IPL. मैं ज़्यादा नहीं देखता. But I'm not a big, let's say, IPL watcher as such. And technically, maybe a very big Dhoni fan also. I mean, I know there was a zone when he was the legend, but I don't think anymore. तो ठीक है, respects there, but अब मैच जीतेगा कि नहीं ऐसे कोई predict नहीं कर सकते है ना. चलो, let's talk about it. So in this you will see a of I plus 1 parity is same, so it will be a false. Question समझ में आ गया? I think you work 22 hours. No, that's not true. I sleep in the morning till afternoon. ये चीज clear है? Do we need like is this problem clear to everyone? Like, can we move to the next one? This is super simple. I think just simply a of I compared with a of I plus 1 should do the trick. Now I think many of you once suggested me, Vivek, we should go through like submissions and the code discussions also, so that like all those make sense. So I'll also, as you guys know, Chandrachur has been helping me with like his submissions so that I don't have to submit all of them. So I'll just go through his code, simply going through like every index except 0, because I minus 1 needs to exist, and you just check that if this parity is equal to the parity of the previous element, then you just false, break, and then you return false. I mean, over here he could directly have returned false, but I think that's another way. Okay, so this is how you can code this particular solution. Yeah, sure. Okay, so this is the first problem. Let's move to the next one. The next one is the array is considered special if every pair of its adjacent element contains two neighbors with different parity. So you are given this, and your task is to check the array. This is special or not, right? Okay, right. This is fairly interesting because we have now queries in the range. Now, when I see this problem, the first thing that triggers in my mind is when can something go false, or when can something go true. So there was obviously a linear algorithm that we discussed in the previous code. We go through the subarray and check whether it's solving that purpose or not. But then 2D nahi hai, it's 2D integer matrix queries. No, this is queries wala part. It's not a 2D input. The input is 1D only. There are queries of L to R ranges, and you have to check. So I'll just simply think about, for a range, what can go wrong? Like, why will it not be a possible answer, right? Why will it be not an answer? Just quick setup. Why will it not be the answer? So we think about array, a subarray portion L to R. Why it will not be an answer? So some element will not be equal to its neighbor, right? Maybe the parity will not be equal to them, then it's fine. But if there are two elements whose parities are same, then that might be a problem. So any two element who has same neighbors will be a problem. So you think about these problematic scenarios in the array, right? You think about the problems that are there in the array, that the neighbors are of the same parity. In that case, what happens is you try to think about, okay, maybe, just maybe, we can think about storing these positions like I and I plus 1 maybe has some conflict that they have the same parity, right? So we can create all these indexes i's and save it somehow, right? We can go through the whole array at the start and save the positions where there are some conflicts. Now what happens is when you are given an L to R query, right? So think about it. There is an L to R zone. We need to make sure that no conflicts occur in this range, right? So we can try and find the first conflict after L. If the first conflict is between these two or anywhere after the R, like after this side, then it's fine. But if the first conflict occurs before that and after L, somewhere in between, then this portion will not be a valid one, right? So it's about detecting the element that is causing the false. It's the conflicts. So you try to maintain the conflicts in some sort of data structure and try to search for the first conflict after L. Does that seem like a good strategy? Does this make sense to everyone? Find the conflicts, save it in some data structure. Maybe after every L, try to find the first conflict and see if it is inside the range that we are querying or not. Is this clear to everyone? Let's try to have a look at how Chandrachud has attempted this question. Oh. So there are two ways with which you can do this. I'll just like discuss both. One is, it's like finding the number of conflicts in the range L to R, right? Finding the like conflicts in the range L to R. So you can do some sort of prefix sum. You can maintain a set of positions where there is a conflict, and then for every query you can do a lower bound and find the first conflict after L, right? And check. Yeah. So there are multiple ways. One is you can use lower bound on a set, lower bound on set of indexes where there is some conflict, right? This is one way. Or you could build some sort of prefix sum that L to R find the number of conflicts. If that is 0, then you have like a valid solution, or you don't have one, right? So these are two techniques that you can use. Lower bound is something that is available in set, so we can use that very, very simply, right? Prefix sum might be an overkill for this problem, but I mean, you can use it. I mean, either way is just about solving the problem, isn't it? So that is what you would look like. That is what the code would look like. That you think about this nums array, find out the conflict positions, right? So I'll just quickly code this up so that we have syntax covered about this or not. Should be less than L. So if it is less than L, the answer is false, right? So vector of Boolean answer, we build this set of conflicts, right? The conflict positions for integer I equal to 0, I is less than n, I plus plus, I is less than nums. Let's build n equal to nums dot size and n minus 1. If we'll try to save the position I if it's conflict. So if nums of I mod 2 is equal to nums of I mod I plus 1 mod 2, then conflict dot insert the position I. Then we have the query. So for auto v in queries, for each query we have the like L and R in v of 0, v of 1. So we now look at integer first, or auto first is equal to like auto it. I'll just iterator, I'll just find it. Auto it is equal to in the conflict set, try to find the lower bound from the query that is 0, like the L. So find the first conflict after L of the query. So wherever this position is, if it is equal to conflict dot end, which means there is no conflict after this, or make sure to write this first, or you have star of IT. So the first one, the value that you get at IT is greater than equal to the end point. So even if the conflict happens at the end point, it's with the next element, right? So that is not a problem. So if it happens with v of 1, then we have like it's fine. Like so answer dot push back true. I think true is what we need to return, else answer dot push back false. Is this what we need to do in this problem? Oh, sorry, we didn't return the vector itself. Clear, everyone, how we use sets and lower bound to solve this problem? That we find the first point which is just after the L in the set using lower bound, and then check with the logic ki acha R se pehle, if we have after R or before R or things like that, right? If it's after R or if it doesn't exist, then we do this and then we do this. Clear? So lower bound is what we use in this case. So set wala cheez you'll have to practice. So 1, 2, 3, 4, 4, 5. Okay. So if we query this much, what will end up happening was the conflict only occurs at the index. What is the index? 0, 1, 2, 3, 4, 5. Okay. Index 3. So conflict mein index 3 hai, right? So when you do lower bound with 1, you find the index 3 and you see ki acha theek hai, index 3 to R ke barabar hai, right? The L and R. So the conflict is with the next element, so it's not in the array. But when we have, let's suppose it like 1 to 4, the conflict happens at index 3, the first element in this conflict array after 1, and it's inside the range, so we say it's not there. Okay. So that's how you do it. Okay, set practice karna hai. So this is something you'll practice over time. Sets, how to use sets and stuff to find the first element after things. Okay, this is something you'll have to practice in STL. Is this problem clear? Idea clear hai? Implementation details you'll have to practice. More these sessions are more for the ideas कि कैसे सोचना है इसके बारे में. Conflict, looking at the conflicts and saving it separately was the main idea. Clear on that? Let's move to the next problem. हाँ जी बताइए फटाफट. समझ में आ रहा है ना? ये सब नहीं आ रहा है ना अभी? अगर STL नहीं पढ़ा है तो नहीं आएगा. अगर STL पढ़ा है तो it should be super easy. ठीक है, don't worry. Let's move to logics. Let's build logics first, and then you guys would be able to solve these problems with these only. Okay. Okay, good. Chalo, next move to the next one, which is sum of digit differences of all pairs. You are given nums consisting of positive integers. Line number 8. Okay, we'll come back to that code. Okay, let's complete all questions and then come back to the syntax doubts. Okay, at coder count is difficult. Pata nahi mujhe. Let's see. Where all integers same number of digits. The digit difference between two integers is count of different digits that are in the same position on the two integers. Count of different digits that are there in the same position. Yes, somebody is mentioning this technique called contribution technique. I think that's what this is. I've covered that on my channel also. So there is something called as contribution technique in this problem. That is what you'll have to use. Or else it might be a little difficult to do, because this is the standard idea when you use contribution technique, that let's think of this number. Okay, 13, 23, 12. इतना तो याद ही रहेगा. 13, 23, 12, right? So one possibility was like whenever you have a problem where you have to find pairwise something, pairwise number of different digits, pairwise number of things like this, right? So in those problems, what end up happening is if you take pairwise and the number of elements is up to 10 to the power 5, you get an order n square solution. ठीक है, मतलब हर pair के लिए iterate करना पड़ेगा, so you get O of n square solution. In many of these counting problems, what you use is something called as contribution technique, right? So instead of going row wise, you generally think about column wise, because कोई भी दो जब लेंगे, since all pairs will be taken, the digits in this column or in this position of the number will always interact with the same position bits. So think about this, कि how many pairs in this position will have a conflict, like these two will have, these two will have, right? So there are two contribution of this position. How many will this position have? There will be 2 to 3 will be a difference, 2 to 3 will be a difference, so there will be 2 over here, right? So if we go back to a problem, this 4 is coming from 2 plus 2 equal to 4, right? So instead of trying to take this number and comparing it with every other number, then taking this and comparing with every other number, which is getting n square, we think of this as column wise. Instead of row wise, you think about this as column wise and try to take each position and try to find its contribution in the answer. How many different pairs will have this digit different, and add that many times to the answer. How many pairs will have this digit as different, add that to my answer. That's my total answer. ये समझ में आया कैसे हो रहा है? Yes or no? This makes sense? Every pair has, like every digit has its own contribution to the answer. Okay, let's look at another example. So the answer is 0 hoga. Nothing much to check. Okay, so nothing much to do, but I'll show you. I think Chandrachud would have done the same thing, so I'll just quickly take his code and show that. No, this is not the best possible code in this. way too hard to think about. Contest mein nahi yaar, it's not hard. If you have practiced contribution technique, right? Find the sum of all subarrays. Find this with different kind of things. Whenever you have digit wise contribution, whenever you have place ka contribution, I always think about contribution technique. So this is something that needs to be clear. This should be in your framework. When I am thinking about a problem and I see there is n square possibilities, but the answer is counting or summing up something and every digit is contributing, ये चीज हमेशा contribution technique होता है. सर टेक्निक्स याद कैसे करें? प्रैक्टिस से होता है मोस्टली. इट जनरली इज प्रैक्टिस, बट द वे आई थिंक अबाउट इट इज यू शुड हैव बिल्ड दिस माइंडसेट बिफोर ओनली, कि जब भी मुझे ये देखेगा आई विल ट्राई टू यूज दिस टेक्निक, कि पेयर वाइज O ऑफ n स्क्वायर हो रहा है, हाउ टू रिड्यूस दिस, बिकॉज देयर इज एवरी डिजिट कॉन्ट्रीब्यूशन इन द प्रॉब्लम. Yes, there is a video on this. I'll quickly show that up in case I find it. Contribution. A very similar problem came back once in Leetcode also. This is older videos, right? So total up, this is also a contribution technique wala video where you have like contribution technique being used. So you guys can search this contribution technique, search karo, you will get video. Okay. Like this is also another example. Like you generally learn these techniques from example. Nobody's going to teach you question like this is this. You generally learn it from examples. Okay. So you generally build a framework for yourself. कि जब भी मुझे ऐसे pair wise दिखेगा, I'll use this technique. Pair wise counting something. इसमें भी ऐसे there are so many digits and you have to try every range. LR O of n square. Make it O of n contribution. Okay, these are reduction tactics that you use quite often. ठीक है? Code कर दो please. Okay, we'll come back to coding. Let's complete all logics and then I'll come back to code. Where to start? I think if you are zero at this point in time, I've inserted a C++ का like link in the description. वो courses start कर सकते हो. It's freely available and you can complete all questions. You should be good at a good place after that. ठीक है, starting करना है तो. Okay, so this is I'll code this particular problem, but let's first move to the next problem also. Okay, I'll cover all the ideas and then we'll come back to coding again. Okay, so I'll come back to coding and then I'll explain it again. Okay, let's cover all the ideas and then we'll come back to coding. Okay, idea 50% समझ में आया? और क्या करोगे? Good. तुमने देखा? I have already uploaded one video which is out of context for the channel, core CS वाला, but I think that's a fairly good video. वो देखना आज 7 बजे. हाँ, this is something I teach. मतलब ये तो एक टेक्निक है जो तुम्हें जानना ही पड़ेगा. Without that you cannot. There's so many techniques that is there. I mean, there is limited 200 to 300 techniques. उसके बाहर प्रॉब्लम बनते ही नहीं है. I feel that's how things are in most of CP. जो लीड कोड पे जितने आते हैं, CF पे आ सकते हैं उसके बाहर, बट लीड कोड पे नहीं आते उसके बाहर. Okay, next problem. पता नहीं यार, I've not seen too many codes yet, so I'll also think about it. I've not seen it. I'll come back to these problems and whichever once you will tell me to code, since like the previous code was not relevant, so I'll try to think about it with this. Okay. So this problem, like you have a jump value and your jump value is increasing. So and this operation cannot be used consecutively, so you can go back one step or 2 to the power jump. So you want to reach the step k. Okay. Okay. Interesting. So the thing in this problem I feel is mostly observation. Okay. I'll come to that. Combination क्या ऐड करना है? I'll try to think about this. Let's think about this. Seems like DP, but समझ नहीं आया when will recursion end. नहीं, my first intuition is not DP. Why? Because maybe like there might be a possibility of cycle, but in this case it is not. So maybe DP. I'll think about it. Okay. So I personally feel that this 2 to the power jumps are getting too fast. What's the value of k? 10 to the power 9. Okay. So 30 moves at max. Okay. This jumps are becoming fast very, very quickly. No, the jump is increasing by 1. So this 2 to the power I wala stuff is increasing quickly. You know? So let's try to think about this. Like I am at, let's suppose I can go to 2 to the power I plus 2 to the power jump, or I can go to I minus 1. This is the diagram, right? This is what you should need to think about in the mind. But then jump increases. So what is my configuration? Like if you try to just think about brute force recursion, right? So you can think about I'm at I can go forward or I can go backward. But if I go backward once, I cannot go backward again, right? That is restricted in the problem. So the two things that is written is, I can go to this, but this cannot be used consecutively or on stair 0. Okay. So if you are on stair 0, then you cannot go back. not allowed. Or if you have done one time, then you cannot do it again. Okay. Interesting. So if you try to do it with some like smart strategy, I feel this might become a little complex, and maybe DP might be one way to go forward. Uh, so DP se zyada yaar, I think what you are doing is essentially counting at most 30 moves. Yeah, exactly. So we can try and like explore all possibilities that reaches to some k. You are at I am at the step I right now. Did I take the last step as back? So last last was a back step, yes or no? What is my value of jump, right? So from this configuration I can decide if last was a if not last was a back, then I can go to I minus 1, right? Possibly I can go to I minus 1 with the last back being true and the jump remaining same, right? And there will be one more condition: if last is not back and I is not equal to 0. So this is what is given. And if like if you jump, so think about it. If the point is k, if you jump to k plus 1 and you go back one step, you can still reach k. But if you reach k plus 2, you can never come back to k. So the limit is k plus 1, right? So if I plus 2 to the power jump is greater than k plus 1, is less than equal to k plus 1, then also I can possibly take that jump. So I'm trying to design some sort of recursion, and some ways of counting. So this is some counting that is happening, but I'm trying to build a state. Okay, I can go till I plus 2 to the power jump. Last was back, no, I did a 2 to the power I jump, so false, right? And then my jump will increase, so jump will become jump plus 1, right? So these are my two options, and this will be built using a plus. Like if either of these happens, then that wave will get added to my answer. The number of ways through this plus the number of ways through this, both of these, how many ways leads me to a k, is what my answer is going to be. Does this make sense to everyone? This is the two strategies that we can possibly do at any point in time. या आई पे खड़े हो, पीछे जाओ या आगे जाओ. That's only, okay. And then you can use this strategy. Base case will be just, I mean, base case will be there will be no ways. So base case is when you have no way to move either way. Okay, that is the base case. There is no fixed number of steps in this, right? So there is no fixed number of steps. हम लोग कोई steps का नहीं रख रहे count. If you cannot move either of the moves, then there will be no more recursion. So that is the base case itself. Okay, a little non-trivial maybe, but since we are not maintaining the number of steps, ideally I think it will like take 20-30 steps only, 30 steps at max, right? And very soon you will start seeing that there is no more solutions. Like the solutions will get pruned very quickly, okay, in this, because as soon as jumps become larger, you will no longer be able to make the number k. Yeah, so that is what will be there, only one stair. So the way I will think about it is number of ways to reach k. Okay, so this I can be up till 10 to power 9. This last back, this is just lead code stuff, I feel. कि कुछ भी डाल दो तो चल जाता है आजकल, ठीक है. This jump will be, around 1, 2, 3 up till 10, 30 possible values. This last back can be 0 or 1, like true or false. This can be 10 to the power 9, but all values will not be reached. All values will not be reached in this case. Okay. From a particular I, you can go to only two values. Okay. From a particular I, you can go to I minus 1 and I plus 2 to the power I. So all values cannot be reached. So from first, you can reach only two possible values. From this, there is only one option. Okay. From this, you will have two options, but some will start getting out very, very quick. So number of states that you will explore is going to be fairly less. तो ये जो आई है ना, इस पे सारे आई एक्सप्लोर कभी होंगे ही नहीं. I mean, think about it. If you are at x, you can go to x minus 1, but you can never go to x minus 2, क्योंकि तुम एक बार डबल जंप कर गए, so you can again do only one back and go forward, right? So पीछे आना बहुत मुश्किल है. Like it's not going to explore everything over here. यहाँ पर x plus 2 पे गए, and you can go back one step, x minus 1. So think about this. X है, I can go to x minus 1, then I can double this, so 2x minus 2. This I can go to 2x, I can go back one step, 2x minus 1, and I can get to 2x plus, just this, right? This much. From these and then from this I can go back, 2x minus 3. From these I will have to make a forward move only, all of these. For all of these I have to make a forward move only, possibly. So फर्स्ट वाले में एक मूव था, फिर इसमें दो मूव था, फिर इसमें चार मूव था, सारे सामने जा रहे हैं बहुत जल्दी, 2 पावर के जंप में करेंगे सारे, राइट? सो द नंबर ऑफ स्पेसेस विल बी सुपर स्मॉल, लाइक एक यहाँ पर 2, यहाँ पर 4, यहाँ पर 8, ऐसे करके. सो यूज अ मैप टू सेव दीज वैल्यूज, दैट शुड डू द ट्रिक. स्ट्रिंग कॉनकैट एज की, I mean, you can do that, but map might make sense. ठीक है. I think map would be way easier to use, I feel. ठीक है. Stringifying things is not the best way in general, so I'll just use a map. Maybe the number of ways. Okay, so number of ways will be, if I am at the step I want to go to, किस पे रखना है मैप में, वेक्टर की. You can do that. I'll teach you a very, very interesting thing today. ठीक है. Jump and integer. एक क्या था, लास्ट टेकन लिया था हमने, लास्ट विल बी अ बैक. वन सेक. लास्ट विल बी अ बैक, लास्ट बैक. ठीक है. इंटीजर जंप. ठीक है. व्हाट इज माय जंप वैल्यू? सो यू आर गिवन द इनिशियल वैल्यूज विल बी recurrence. I am starting at which step? Stair 1. My last back was, no, I didn't take a 0. Last stair on stair 1 wants to reach k. So jump value is also, jump value कितना है start में? What is the initial jump value? 0. Okay. ठीक है. Return this. Okay. And this k needs to be passed on target. I'll just pass this in the recursion only, but I don't need to save it because it's fixed value. So I'll just pass it here. Okay. Now I need to save this. Okay, I need to save this. So one strategy I can do is I can just first write the recursion. Number of ways, integer answer equal to 0. Okay. Can k be equal to 1? So this is a very interesting case. अच्छा, they had given the input k equal to 1. यही तो सबसे tricky था. If they would have given, if they would have not given this input, I think this would have been an edge case for many people. There would be many more wrong answers, right? So by default, if you are at k equal to 1, there is a one way, which is don't jump. So if I is equal to target, then there is one possible way, which is answer plus plus. Okay. And then there are two more possibilities from here forth, that if last back was false, if last back was not there, I mean it's a false value, or I is not equal to 0, if last back is false, yeah, and I is not equal to 0, I don't think you can ever go below 0. So this condition might not be even relevant. because if like this will make sure that it never goes below that. I think so. I'll have to see. For one, no, 2x minus 3 was there also. So in some case it might be. So last back, this. What to do next? Answer plus equals to the number of ways if you take a back step I minus 1. Last back will be forcefully 1. You have taken a back move. Jump will remain the same. Target remains the same. If jump plus, sorry, if I plus 2 to the power jump, and I hope this doesn't exceed, let's make it LL, okay, is less than equal to the target plus 1, because we can only go back one step. Then answer plus equals to this should be good enough, I feel. And jump will increase, and this will be 0. Okay, return answer. So this is the brute force. So I'll just check if this brute force is working for sample. Okay, so it's working for sample. So either your values will decrease or the jump will increase. So it's a DAG for sure. So we can use DP. First, I generally think about this. Can I surely use DP in this problem? Because either your I will decrease or your jump will increase, right? If your value is increasing. So either I'll go back or I'll go to the next level. So it's a DAG for sure. This graph will be a DAG, so I can use a DP. Okay. Then I need to save this. So what I'll do is I'll make a, so since this is like 2D wala stuff, I'll just show you one more trick, or I'll just want to check also. Unordered map of int okay. What is this, Vivek? What did you build? Okay. DP of I last back dot jump dot find jump. विवेक ये क्या है? कोई बताएगा मुझे, समझाएगा ये क्या है ये चीज? I think I've shown it in some previous stream, no? नहीं है क्या? कुछ गलत लिखा गया? Unordered map, unordered map, unordered map. Find नहीं होता है क्या? Oh, sorry. Is not equal to dp of I dot end. Still it's working. And maybe if we submit, let's see if an ordered map works. I want to check this, but Leetcode being Leetcode, I don't think that will fail. What is this way of writing? See, it looks like it's a 2D array, a 3D array only, right? The way you store it in DP arrays, but it's not. What exactly is this? Vivek, which crafty things are you using? So this is a way of creating infinite sized n-dimensional array. If you have 1 dimension, 2 dimension, 3 dimensions, store a value inside it. I can create any possible values. That's also a super interesting thing. We can derive the I from the number of backs and number of jumps taken. So maybe, just maybe, I can, I mean, you don't need to make it a state in the DP. Perfect, that's a very good idea. But let's think about it. You don't need one level in this DP. No, how will you make? Then you'll have to maintain the number of backs taken. Number of backs you'll have to maintain. No, number of backs that you have taken is what you'll have to maintain. No, no, that's not true. You have to maintain the number of backs in that case as a state. Okay. So this is one possible way of recursion. Okay, doing it with recursion. Now you can try it with like direct combinations or trying to see the bits and stuff. Let's try to do it that way also. I think that should be interesting. This is a way of creating infinite sized array. So see, I'm writing unordered map as um. Okay, unordered map is um. So what does this do? Does this give you an illusion of infinite sized array? Yes or no? Does this give you an illusion of infinite size array, like MP of 3 can be equal to 2, things like that? Yes or no? This is a illusion of 1D array, correct? So I'm also like the number of states will be less only. It's just that it's not required to write one of the states, and the very few number of states will be visited. So that's why we are doing this. Okay. So then unordered map. So now what we are creating is unordered map of integer to a 1D array. So what happens now is for every like infinite number of rows, you have an infinite sized columns. So it's like an illusion of 2D array. समझ में आ रहा है? So that means if you write unordered map of integer to unordered map of integer to integer, this is a illusion of 2D array. इस int के लिए finally ये value आएगा. So you can write MP of 3 for this int. In that, whatever the map is there, in that 2, what is the value saved? 5. So this is a very neat trick that you can use in some problem where you have to, when you know that a lot of things will not be visited, but you want the illusion of having a infinite sized array. Clear, everyone? This is a very neat trick that you can someday use in a problem. I samajh mein? So this is something I've used to save. I think this problem can also be solved with like mathematics a little bit. That hey, let's try to loop through the number of back steps that I will take. You know? So let's say that you have taken X back steps, right? So back. Okay. So so all these were valid. So if you were at I, you are potentially at I minus X, and I need to reach K. So I know how many 2 to the power 0, 2 to the power 1, you will, there is exactly one way in which you can make the 2 to the power jumps, right? There is exactly one way in which you can make the 2 to the power jumps, because you have 2 to the power 0 to be taken or not, then 2 to the power 1 to be taken or not exactly once, then 2 to the power 2 to be taken or not. I think you have to take it exactly once, right? There's exactly one possibility that you have to take all of them, some starting prefix of it. नहीं होती है, but it's अब 3D array बन गया ना, like it's so easy to make 3D array. Vector of int पे तो you have to define the size, all the elements in between needs to be created अगर तुम्हें इसको भी access करना है तो, but in map you don't need to. No, that's an overview. That's an overview video. So it's like the precondition of everything that you need to know about CS concepts. Okay. So somebody's asking about the video that I uploaded. Watch it. You will enjoy it for sure. I think that is one lecture that every college should have before their core subjects, because it just makes them so reliant. Yes. So this is also something you can try and do, that loop on the number of back steps that you take, and then these are the steps to be taken, right? So you can either place them like how many of them go in between the backs is what you do. Okay, and there will be some maths. How many of you did it with maths, something like this? ऐसा कुछ maths किसी ने करा क्या? I think maths is also possible in this problem. How many of you did with some combinatorics maths? Let's see. Somebody was saying no कि मैं maths से करा. कुछ ऐसा कर सकते हैं. I feel that if I know the number of back steps, I know which all things I'll need to fill. So now this is not mandatory, but these gaps, like these x-1 gaps are mandatory. So you have to fill the number of steps you are taking to go from here to here. There are like let's say some y number of steps based on the difference and the bit representation. I have to fill these y's in this x-1 gaps or in x plus 1 gaps such that these x-1s are non-zero. So you can build a maths around it and you can write a maths formula. That's also another strategy that you can use. Okay? And I don't think the back steps can be more than 30. So you can just loop over 30 for 30. And then, because two back steps can't be there. So one back step, then 1 2 to the power I. So in 30 steps, you will be exhausting your 2 to the power I wala moves. So 30 steps possible, max to max, 30, 40 steps, try them. And then for each one of them, you can write a maths formula. So it should be order 30 solution. Right? But this is little more mathsy. I don't love to, I love maths, but I don't want to make it more mathsy in the sessions because I know that many of you fear maths. So it's better to practice with recurrences, right? Recurrences are way easier. समझ में आ गया ये चीज, ये recurrence समझ में आया? This is like forget about DP and stuff. This is just a simple addition over here, right? By the way, why did this work without even clearing the DP? Just Leetcode things. Chalo, chodo. Ideally, you should have written dp.clear. Is there any test case in this problem? Let's try to submit the brute force once. No? Let's see if this passes. Because there can be 30 steps. So, some return needs to be there. Chalo, time limit exceeded are at least these cases they have created. Okay, so you have to use DP so that you don't recompute the states again. Obviously, like recursion is like way 2 to the power 30-ish kind of recursion, right? So it will never pass. It shouldn't pass, but I was just checking Leetcode. So if you just save the same value coming again and again, then you can make it work, right? This is something that will work for sure. So this is the main idea. How to model this in your configuration, that I am at step I, what was the last step taken? Was it a back or not? This is the jump. How many jumps have I taken till now? Or what was the last jump size? If I take a jump, then the next time I have to take jump plus 1 size, jumped to the about jump plus 1 size. And that's it. That's all you maintain. So whatever is relevant at your current point is what you maintain in your states. Okay. So that should be the idea. भैया इलेक्शन में किसको जिता रहे हो? ये देखो भाई, ये देखो, ये सब पॉलिटिकल क्वेश्चन नहीं पूछने का इधर, ठीक है? खासकर टीचर लोगों से तो बिल्कुल भी नहीं. Why this? So if you are already at the target, you can possibly do these things. But there is one more interesting thing that you can do. You can stop. You cannot make it. Even if you don't make a move, you still get a number of ways. मतलब इसमें क्या लिखा हुआ है? If you are at I and you want to be at I, so there is one possible way. What is that? Don't move and you will be at I. But then one possibility is you can go forward and then come back one step. तो ये भी कर सकते हो तुम चाहो तो. That you can go forward and then come back one step, and that will also be one more solution. Okay. So if you are at 1, then you can come back at 1 that way also. Clear? This is why this is the base case itself. And then if there is a possibility, like soon enough, this will exhaust and this will exhaust. So the recursion will stop going forward and it will just return zeros. Okay. Soon enough, it will make the highest possible jump. उससे ज़्यादा jump करेगा तो सीधा k के बाहर. And then it has also taken one step back, but neither back is available nor to the power I jump is available. So that's the base case. Okay. This is how you can do it. And this is another trick I taught you. You can use vectors in map and all those things, but this is another trick I taught you. 3D infinite sized array. कुछ भी access कर लो. You can access any value, save any value, retrieve any value in this 3D array. ठीक है? Without even knowing the sizes. Neat, isn't it? Like obviously there is an overhead of unordered map, but still works. Clear? Okay. Somebody is saying, let's go back to 3 a little bit and talk about it again once more. Let's try to code this also real quick. The contribution technique idea. So we were thinking about these numbers, right? And the numbers are, what is the length? These many number of values, and you have the numbers at 10 to the power 9, less than 10 to the power 9. So there is 9 digits exactly. 10 to the power 9 has 10 digits, less than that has 10 to the power 9 digits. So I'll obviously try to make it, interval map chalega. Hash map बोल देना बस, है ना? There is this famous video ना, जोमा टेक करके जिसका यूट्यूबर का एक वीडियो कि किसी भी प्रॉब्लम पे हैश मैप से करें कुछ. So these are the numbers that is given to us. I want to like go digit by digit. So I'll try to think about what will I think about. I'll think about every digit one by one, right? So for what I'll do is I'll just build strings out of them because I want to access the ith digit very, very quick. So I'll just build a string num for auto v in nums number dot pushback. You have this function called toString, right? toString the value v and save it in the num array, right? Integer n equal to num dot size. So now I'll go through the position in the number, right? And the integer length is equal to num of 0. I mean, now we have converted to string, so let's use that array only, dot length, right? This is the length of the digits. So what I'm doing is I'm doing this. I'm finding this as n and this as my length. Okay, this is my length. So I'll go through my length instead of numbers. So I could have done this for integer I equal to 0, I is less than n. For integer j equal to I, j is I plus 1, j is less than n, j plus plus, and some sort of answer plus equals to function of num of I, num of j, कि ith या jth number के बीच में जो भी है answer, like number of digits different, add them to the answer, something like that. I could have done it this way, but this would have been O of n square. The way contribution technique works is it flips the matrix. So what we do is we go through the length. Okay, the length in this, and then we go through every number. For auto, v in the number, we go through every string, and I'll just build the frequency array, because what is the logic? If in a particular position you have 1 2 1 3, so let's think about this: 1 2 1 3. So 1 can interact with 2 and 3, it will give a difference pair, right? 2 can interact with anything except itself, so 1 and 3. 1 can interact with 2 and 3, 3 can interact with all the 3. So you can count all these pairs and divide it by 2, because everything is getting counted twice. That is what I'll do. So 1 can interact with everything except itself. So I'll try to count the frequency of every number, integer frequency of 10. I'll create a vector with all frequencies being 0. I'll go through the numbers, and for the ith position of the numbers, what I'll do is frequency of v is ith digit in its number form plus plus. So this is a string, ith bit is the string character of that digit. So let's say it's a 3. So in its number form, do that plus plus, okay? And then I'll calculate the answer. Can the answer be long? I think, yeah, makes sense. Right? And for this particular position, long contribution equal to 0. What I'll go through every possible frequency for integer I equal to 0, I is less than 10, I plus plus. What I'll do is I'll just think about it can interact with everything else. Total integer. Total is obviously the size of nums, which is n. So contribution plus equals to the every number which has the I in its current length. This I and I will become same. Sorry, I'll make this j. Every number who has j in its ith bit, it can interact with everything else. So what I can do is I can just simply think about every number having j, which is nothing but frequency of j, can interact with every number that doesn't has frequency of j, right? And this sum can be added, and then everything can be divided by 2, because every interaction has been counted twice. And then final answer plus equals to the contribution of this particular position. Now, since this can exceed the limit, I'll just make this 1 and I'll multiply it, and this should be it. So what we are doing, we are going through every bit position, every every position. In that position, we are finding what are the different numbers that are present in all the numbers, okay, and building their frequency. And now once you have the frequency, in the ith position you have 1 2 1 3. I'll make 1 is present twice, 2 is present once, 3 is present once. Now what I'm doing is this 2 can interact with everything else, which is 2. So total is 4. 2 can interact with everything else, so 2 into 4 minus 2. This 1 can interact with everything else, so 1 into 4 minus 1. This 1 can interact with everything except itself, so 1 into 4 minus 1. And since this has been counted with this has been counted with this, so I'll divide the total sum, divide by 2. Final answer, divide by 2. So this sum will come up as whatever it comes up, we'll divide it by 2. 2 into 2, 4. This will be 4 into 3, 3. This will be 6, 6, 10. Divide by 2, 5. See, there are exactly 5 pairs. 1, 2, 3, 4, 5. There is no more pair existing in this particular column. Okay, these are the interactions that we have counted over here. Do it for every column, because every pair will anyways get counted in that way itself. You are done with the problem. So what we are doing is thinking about one, 3, 2, 3, 1, 3, 1, 2. Okay. Instead of comparing these two, and then these two, we are thinking, hey, forget about individual full number comparison. Think about only this position, this two, and this two, and then doing this. When you have to reduce the dimensions, when O of n square is too much, and then you want to reduce it. Okay? So this is thinking about each bit, each position. In each position, you try to think about, in that position, in the ith position, across all the numbers in that list, go through the numbers and build its frequency. Find that for every value, like if it is a 4, it can interact with everything. A 4 can interact with everything except 4. So n minus frequency will be everything except 4, divided by 2, because every contribution was counted twice. That is the number of pair. That is how many pairs will have different bit in this particular position. Okay, and then you can add it to the answer. The other video is much simpler than this. This is a little harder example of bit contribution. So this is O of, let's say, 10. This is O of n. So the code just becomes O of n into 10. Right? This is a harder example of bit contribution. Okay. So this is 10 into n only. It's way faster. Okay. But it's a very beautiful problem. Make sure to solve it after, like, watch it n number of times, understand contribution technique, watch this video n number of times, try to understand why is it working. If you understand this technique, you can solve so many problems. In fact, bit contribution is, I'm saying position contribution is most common in bitwise problems, right? A very, very, like, I can give you many more examples of bit problems, contribution technique problems. Like, hey, find out sum of all sub arrays of an array, right? Or for an array given to you, find double summation ARR of I XOR ARR of j, right? Or you can think about find number of distinct characters in every subarray. There's so many variations. I can keep creating more and more questions, right? So this is all ideas of bit contribution that you can try and use. Okay. Not bit contribution, contribution technique. Bit contribution is just this. Okay. There's so many ideas like this that exist. And if you know just enough number of ideas, you should be able to solve any problem technically. I mean, that's what practicing in CP means, I feel. Just collecting more and more techniques that can come. Okay, cool. I think that should be it for the discussion. I think we have discussed almost all of it. Any other queries on the questions? Chalo, thankfully the light didn't go. I'm super happy. We discussed almost everything needed. These days I have to think more about कि light जाएगी क्या class के बीच. I'll get the inverter fixed ASAP. भैया डबल ई कैसे होगा? डबल ई क्या है ये? समझ में आया? डबल पाउंड क्या बोलना चाहते हो? है ना? ये तो डिस्कस कर लिया था हमने, कॉन्फ्लिक्ट वाला सेट वाला आइडिया, contribution technique, just TP. When you know that things are less in number of states, just throw DP at that problem. You can watch the videos on my channel. I think they should teach you fair number of tricks that you need. If you watch all the There used to be a lot of more videos I used to create earlier, and the older videos are actually golden if you go through them to learn new CP tricks. Live streams that I've taken on Manhattan, all the way to maths techniques that I've covered on the channel. They are fairly valuable, I feel, if you complete them. Huh, yes, in the last problem, correct. This is because you have this. No move is also a way. DP के लिए DP workshop कर लो, that's fairly. Once you have the forms of DP, then it becomes super easy to think कि क्या सोचे हम. जैसे ये भी जैसे दो स्टेट है, दो टेक मतलब what which transition to take, sort of form one only, right? डबल समेशन जो आप अभी वेरिएशन बता रहे हैं थे कंट्रीब्यूशन की. करो भाई करो, अच्छे अच्छे क्वेश्चन है बहुत सारे, दुनिया में क्वेश्चंस की कमी नहीं है. वो भी वैसे ही होगा, हर बिट का कंट्रीब्यूशन निकालो, कितने सारे पेयर्स में वो बिट वन होगा. तो मैथ्स तो अच्छा करना ही पड़ेगा. आई मीन एवरी अदर प्रॉब्लम इज गोइंग टू बी मैथ्स मोस्ट प्रोबब्ली. हाँ, I made the forms mostly. LRDP and stuff existed, but I make, that's my work. No, I make things to make it easier to for the students. That's my work of as a teacher. How can I build things that can make it easier? है ना? I don't think you'll also. I mean, contribution technique people understand that way, but I don't think somebody would have made proper explanation around contribution technique also. Problem solving is something that takes good amount of time. How you learn all those techniques. So I'll tell you. People ask me, Vivek, how can I make techniques myself, or how can I extract blueprints of every problem? The answer is you can't, because I can see this now, because I have solved 3,000, 4,000, 5,000. I've seen 5,000 problems. I've potentially solved them in mind. I've solved 3,000 problem in code. And now I can see a problem that these are the classes. Now, once you have like, this is very, very interesting. Once you see, like if you have solved 3 problems, what can you do? But once you have solved so many problems, you can understand that there is some cluster here, some cluster here, some cluster here, and then you can say that this is form 1, this is form 2, this is form 3. Okay, so technically you cannot do this yourself. You cannot extract a pattern yourself, you'll have to read it. This is how it works. That you see so many examples that you realize that there are these common questions that are coming so many times. Maybe cluster them together and try to create a technique that can solve all of these together. CodeChef का पता नहीं है, CodeChef rating system तो क्या ही है पता नहीं मुझे. I don't recommend CodeChef anymore to anybody. I mean, for beginners, the starters is good, but questions are good. But in general, I am no longer a big fan of CodeChef. AdCoder and CF are much better. DP वर्कशॉप खत्म करो भाई. एसवीएम तुम्हारे पास तो अभी 4 पॉइंट है, तुम तो डीपी में अभी 10 प्रॉब्लम करके रखो. क्या एसवीएम लगाओ इस पे? क्या क्या दिखेगा तुमको इसमें, है ना? But then once you solve so many problems that you start seeing कि ऐसा कुछ है, obviously there will be outliers and stuff, but once you start seeing so many problems, तब समझ आएगा, oh shit, ये तो एक ही जैसा बट रहा है ये सारे के सारे, है ना? This is exactly what a work of a teacher is. ठीक है. Cool, yeah, I'll keep teaching more and more things. We'll discuss more problems, but अभी के लिए लीड कोड वीकली तो हो गया सॉल्व पूरा पूरा. Okay, 7 o'clock पे there is this cool session. देखना, you will most probably be able to see this in that session. क्या है ये पता है क्या किसी को? You know what this is? हाँ अभी जैसे greedy वाला techniques will be there. Big fans. Check वाला. Motherboard, yes, essentially. Correct. I don't know how many of you have opened computers and all. RAM and stuff, placing them in this. यही पढ़ा है मैंने कोर CS वाला. The video is streamed on 7 p.m. देख सकते हो वो बैठ के, बहुत अच्छा है. मतलब मुझे ऐसा लगता है कि everybody should watch that one. Like I feel Indian graduates graduate without even knowing computer science है क्या. मतलब कभी ऐसा कंप्यूटर नहीं देखा पर कंप्यूटर साइंस का डिग्री मिल गया है, राइट. That's how it happens. तो वो एक बार देखना, you will get full clarity of all the subjects that exist कि क्यों है वो सब्जेक्ट एग्जिस्ट क्यों करता है. Then you can start reading about कि OS में और डेप्थ में अच्छा ये शेड्यूलिंग ये होता है वो होता है, all these things in depth you can read. But this is the first class that every college should have, which is missing I feel in computer science syllabus. कि भाई कनेक्ट कैसे हो रहा है ये सब चीजें, वो तो समझाओ मुझे. कंप्यूटर्स काम क्यों कर रहा है, कैसे क्या कर रहा है, क्या हो रहा है, वो नहीं है. बाकी उसके बाद तो पढ़ना, थियोरेटिकल चीजें तो एग्जिस्ट करती है. हाँ, retake things I'll keep adding more and more. अभी I think ICPSC camp में भी there is going to be so many, like week 6, 7, 8 I'll take. उसमें तो I'll teach you guys constructive and 3D ad hoc ideas. उसके भी जितने पैटर्न्स है मैं तो दिखा दूंगा. मतलब उसमें भी 8 से 9 ही आइडियाज है जो इतनी बार आ रहे हैं कि वही कर लो तो CF के 90% क्वेश्चन हो जाए तुमसे. कि तुम ऐसे लिस्ट बना के रखो, तुम क्वेश्चन देखो, लिस्ट नहीं अरे यही होगा, ऐसे ही सॉल्व हो जाए सारा 90% क्वेश्चन CD तक. Instead of encountering techniques in question, is there a get to all techniques beforehand? I mean, you'll have to solve questions for that for sure. Formal language. I don't think there is any exhaustive list as such. नहीं तो हर कोई हर क्वेश्चन कर लेता मेरे ख्याल से at this point in time. ठीक है. Chalo yaar, I think this should be it. We'll meet again in the next session. Like, we'll try to learn more of frameworks and stuff. I'll teach you some more frameworks. I'm thinking of talking about strings. That is also one place where I feel a lot of people don't have good amount of idea, but there can be a lot of learning. Strings is something we can cover, and it's my specialty actually. CSS वाला तो करेंगे, CSS वाला इंट्रोडक्शन अभी ICPC कैंप भी मैं कराऊंगा, so I'll add that to YouTube for sure. Game theory का यार, there is this book which you have to read, which I read for a world finals. उसमें सारे आइडियाज है जितने क्वेश्चंस वगैरह बनते हैं, बाकी तो ऑब्जर्वेशन. When I'm on my phone, I can't comment. I can comment, but when I'm on PC, I can't. Is it so? By any chance, did I make this subscriber only? That might be a reason. Shouldn't have been, but let me check. Is that my settings at this point in time? I think that should be a good enough check on the chat. कि कोई कुछ भी आके लिख के ना जाए. Even if it's on, I think it's on. मैंने last stream में करा था ICPSC वाले में. तो बेसिक तो सबके लिए है ना भाई. ICPSC क्या वैसे थोड़ी है. 4 वीक होने तो नेक्स्ट वीक से तुम्हें मजा आने लगेगा. नेक्स्ट वीक के क्वेश्चन बनने बंद हो जाएंगे तुमसे. कौन सी बुक नहीं है, कोई PDF था यार. I don't have it at this moment. I'll look for it. I don't remember. I prepared it for world finals, I remember, but that's 4 years back. ठीक है, so I'll look into it. The game theory CF पे बहुत आता है, एड कोडर पे भी आता है, but बाहर नहीं. So I have been mostly like going through a lot of like internship placement stuffs these days, right? By the virtue that I have teach at AZ, तो मेरा आजकल बहुत ज़्यादा वो हो गया है कि इंटर्नशिप प्लेसमेंट के क्वेश्चंस देख के, कोडिंग टेस्ट के क्वेश्चन देख के, दैट्स व्हाट आई हैव बीन लुकिंग एट मोस्ट ऑफ माय डे. तो वो हो गया है, बट लाइक I'll curate more of CP resources soon enough and add. ठीक है. Graph is game theory is another good resource. I understand that क्योंकि उस पे there is like good amount of standard games that you should know, तभी क्वेश्चन सॉल्व होंगे, and some invariant proofs की ये स्टेट हमेशा लूजिंग क्यों है, बाई प्रूफ यू कैन डू दैट। डेव कैसे स्टार्ट करें, इसके ऊपर प्रॉपर एक वीडियो बनाते हैं डेव स्टार्ट करने के ऊपर। डेव में यार आई थिंक यू कैन गेट रियली गुड इफ यू, मैं वही कर रहा था मैं बैठ के, कहाँ गया मेरा डॉकर कंटेनर, मैं बैठ के कोड ही लिख रहा था बहुत सारे। हाँ मतलब मैंने बहुत ज़्यादा कर रखा है, प्लस आई थिंक आई हैव अ गुड मेमोरी, सो मैं भूलता भी कम ही हूँ, तो ठीक है, तो सब याद है मेरे को। बट क्योंकि मैंने सब चीज़ 2-3 बार कर लिया, इसीलिए बार बार रिवाइज करा ICPC के लिए, इसीलिए मुझे याद है, ऐसा नहीं। Can I make a backend only project? Yes, you can, but I think the market is such that you should try both. Okay. चलो यार, this will be it for today. Next there is 7 PM पे stream. अगर तुम्हें कोर CS वाला पढ़ना है, that's super interesting, पक्के से देखना, and I think you'll enjoy it. ठीक है भाई। स्प्रिंग बूट सही है क्या? हाँ सही है यार, आई थिंक जावा स्प्रिंग बूट का अच्छा खासा हायरिंग होता है इंडिया में, बट आउट ऑफ इंडिया मे बी नॉट सो मच, इंडिया में काफ़ी अच्छा अपॉर्चुनिटी। if you want to look for remote and stuff, Django would be a better suit to build. भैया 3rd ईयर में हूँ, DSA करता हूँ, डेव का मन नहीं होता, कैसे करूँ? करना तो पड़ेगा, प्रोजेक्ट बनाओ यार, कुछ मोटिवेशन होना चाहिए कुछ बनाने का, क्योंकि तुम जब तक ट्यूटोरियल देख के छापोगे तब तक तो कुछ होने नहीं वाला वैसे भी, तो कुछ मोटिवेशन होना चाहिए कि ये मुझे बनाना है हैकाथॉन के लिए। अनलेस फाइंड अ पर्पस एंड लर्न डेव फॉर दैट, अनलेस यू डू दैट यू विल नॉट बी एबल टू डू डेव। तो मैं ऐसे रैंडमली मैं कुछ कुछ सीख के कर दूं तो कोई फायदा नहीं है। तो 8 मिनट्स, yes 8 मिनट विल स्टार्ट। ठीक है चलो, if that's there then let's wrap it up for today. Thanks for joining in guys, we will have the discussion again in next week. ये चीज तो मैं कंटिन्यू करूंगा because I just wanted to make sure कि this is something we are consistent on. हर वीक कुछ कुछ सीखना होगा तो हर वीक ज्वाइन करो, हर वीक सीखोगे कुछ ना कुछ नया, राइट? Chalo then. Bye bye everyone. Have a great day ahead. See you all.